Yo, Code Pilots! Welcome to Part 5 of the Python OOP Masterclass. We've mastered inheritance, and now we're exploring polymorphism. This will be a deep dive with lots of explanations. So hit that like button, and let's get going. Let's talk about what polymorphism is and why it's exciting. Polymorphism means many forms. It lets objects of different classes be treated as instances of a common parent class, even if they behave differently. Imagine a garage where all vehicles, cars, trucks, can move, but each does it its own way. This flexibility is powerful because it lets us write code that works with any child class without knowing its type ahead of time. Today, we'll see how this works with our car examples. So let's think about why this could make our programs more adaptable. To start, let's recall our vehicle class from last time, which has a move method. We're going to use it as the parent class again. The idea here is to let different types of vehicles inherit from it, but each can redefine move to suit itself. This is the foundation of polymorphism, and it's worth taking a moment to appreciate how it sets up a shared interface. Let's set the stage by looking at that class again. Now let's think about why we want to use polymorphism. Imagine you're building a racing game where different cars need to move differently. A regular car cruises, a sports car races. Instead of writing separate code for each, polymorphism lets us use one function to handle all types. This saves time and makes the code easier to maintain. So let's create a car class again, inheriting from vehicle, and we'll add a custom move. Let's plan this out before jumping in. Let's build the car class. We'll use class car vehicle with def init self speed brand to set self brand and call super init speed. Then let's override move to print something like car self brand is cruising at self speed kilometers per hour. The goal here is to show how the child can change the parent's behavior. Let's add this and take a breath to see what we've done. Before we test, let's discuss what we're achieving. By overriding move, we're giving car its own identity, while still fitting into the vehicle family. This is the heart of polymorphism. Different forms under one roof. Now let's test it. Create my car equals car 100 Toyota and run mycar.move to see the cruising message. Take a moment to watch the output and think about how this differs from the parent. Let's add another vehicle type to see polymorphism in action. We'll create a sports car class, also inheriting from vehicle, with def init self speed brand top speed and a move method that prints sports self brand is racing at self speed kilometers per hour. The reason we're doing this is to show how multiple classes can offer different behaviors under the same method name. Let's set this up. Let's test the sports car too. Create my sports car equals sports car 200 Ferrari 300 and run my sports car.move to see the racing message. This reinforces our point. Both car and sports car use move, but each does it differently. Pause here to let that sink in and think about the flexibility this gives us. Now let's talk about why a function can treat these differently. We'll create a move vehicle function that takes any vehicle object and calls move. The beauty here is that it works for any child class without us needing to check its type, saving us from writing repetitive code. Let's add this function and plan how we'll test it. Let's test move vehicle. Define def move vehicle, vehicle.move, then call it with move vehicle my car, and move vehicle, my sports car. Watch the different outputs. This is polymorphism at work. The function doesn't care which vehicle it gets. It just triggers the right behavior. Take time to discuss why this is a game changer for coding. Let's apply this to a practical example. We'll use a racetrack class with a method startRace that takes a list of vehicle objects and calls move on each. This mimics a real scenario where different cars race in their own style. Let's set this up and think about how it leverages polymorphism. Test the racetrack. Create racetrack equals racetrack. Add my car and my sports car to a list. And run racetrack.startRace with my car and my sports car. See how each vehicle moves differently. This shows polymorphism in a race context. Pause to explore the result. Let's enhance startRace to declare a winner based on speed. Modify it to find the fastest vehicle and print the result. This adds a practical twist. Let's update and test it to see who wins. Test the winner feature. Run the race again and check the output to see the fastest vehicle. This wraps up how polymorphism, combined with inheritance, powers dynamic applications. Take a moment to reflect on this. That's a wrap for Part 5, Code Pilots. You've mastered polymorphism with car examples. Like this, subscribe and experiment with your own polymorphic designs. See you in Part 6. Keep coding.